My name is Jason Alvey. We've all been told that the Earth turns, that it's spinning around on its axis. But when I look around, I can tell you, it doesn't look like this. It all looks still and in one place to me. So let's explore how it was first shown that the Earth is actually spinning. Back in 1851, a French scientist named Jean Foucault displayed an experiment at the Paris Observatory. It was called the Foucault pendulum. It consisted of a large, heavy pendulum, or bob, a long wire, a pivot that moved freely, and the Earth below. Louisville, Kentucky is home to not just one, but two Foucault pendulums. Now let's take a closer look to see what type of science they have to offer. Grawemeyer Hall is an administrative building on the University of Louisville campus. It houses amazing architectural design and also classic art. It also happens to be the home of the university's Foucault pendulum. Here we are inside Grawemeyer Hall, located on the University of Louisville campus in Louisville, Kentucky. This Foucault pendulum was installed in 1978 as a simple demonstration of the Earth's rotation. The pendulum is suspended by a 72-foot wire. Its bob weighs about 150 pounds. It uses a magnetic ring assembly near the pivot point to give a little extra pull to the wire to compensate for any drag. This allows for the non-stop continuous movement of the pendulum over long periods of time. The other Foucault pendulum, located in the area, is at the Louisville Science Center in downtown Louisville. This pendulum operates the same as the one from the University of Louisville, with one exception. It does not have the magnetic ring to help maintain its momentum. Therefore, it needs to be restarted by hand quite often. The Coriolis effect occurs when an object is removed from a rotating surface. Now let's look at an example. Here we are at Peggy Baker Park in beautiful Oldham County, Kentucky. We're going to perform a simple demonstration to show how the Coriolis force affects an object when it's displaced from a rotating frame of reference. Let's now look at a chart that displays how the Coriolis effect works. On the left-hand side, we have person A, who is on a rotating surface with a ball. They are going to throw the ball to person B, who is not on the rotating surface. On the right-hand side, we see what person A sees from their point of view. Person A will see the ball deflecting off to the right toward person B. Now let's see how this looks in real life. Now let's take a look at what person B sees. Person B sees person A release the ball at the 12 o'clock position. The ball travels straight through the air to person B. When person B catches the ball, person A is in the 9 o'clock position. Now let's see what this looks like on the playground. The Coriolis force affects things in everyday life all around us. The weather and wind are touched by the effect. Airplanes have to adjust their destination coordinates because of it. Even water slides around on the surface of the earth, altered by the effect. All because these things are not directly attached to the earth's rotating surface. Now that we have a better understanding of how objects act when removed from a rotating surface, let's take another look at our Foucault pendulums. In the picture, we have a bob that is attached to a wire. The wire is connected to the ceiling at a pivot that allows the bob to swing freely in any direction. When the bob is swung, it will travel in a straight path and remain swinging that direction until it runs out of momentum. At first, we don't notice anything strange. The Earth is so big, it takes a little time to show us what's actually happening. As time goes on, the bob appears to be changing direction, deflecting off the preset path it was sent down. Since we know that the bob can only move in a straight line, the conclusion is that the Earth must be moving under it. In 1851, Jean Foucault was the first to publicly demonstrate and prove that the Earth was, in fact, rotating. Thanks to Jean Foucault, we now have proof that the Earth rotates. This helps us to better understand not only the world around us, but the world that turns below us.